Okay, so on number 12, it says the volume of a cube with side length x is given by volume equals x cubed. And the first thing he wants you to do is graph this equation. So we're going to let this h of x be our volume, represent our volume. This then is the graph. Okay, use your graph to estimate to the nearest half unit. Number 1, the volume of a cube whose side length is 1.5 units. Well, if this represents, right here, if this is, if our x-axis is our side length, x-axis is our side length, then all we need to do is go ahead and construct go to 1.5 units, which would be right here. And if we draw a line straight up, it's going to intersect with the graph right there. And then we're just going to come straight across to approximately right here. And looking at this, it's probably our volume. If our y-axis represents the volume, if that represents our volume right here, our y-axis, then this would be approximately 3.4 cubic units. So for BI, volume is approximately 3.4 cubic units. And that graph, of course, is fairly accurate. So I bet you if you went 1.5 cubed, and we can actually do that here. Let's go ahead and do a calculation. So if we go 1.5 cubed, blew that. Do it on the calculator here. 1.5 to the third power. I wind up getting 3.375, which is very close. So that's going to be equal to, okay, so that's going to be equal to 3.375, approximately 3.4 cubic units. Again, your measurement is only going to, your accuracy is going to be dependent upon how accurate your graph is. Okay. Now, the side length of a cube whose volume is 10. All right. So if I had to take and rearrange now let's go ahead and let's get rid of this. Oh, I didn't want to do that. Let's try that again. So all I want to do is get rid of this one line. Get rid of this line. Okay, so now if I wanted to bring this in so that I can see 10, you can see I'm going to have an issue, right? Because this gets really steep. So if I were to bring a line and try and do this graphically, bring this up, this is going to be a long time in coming. Matter of fact, if I did the calculation and actually went ahead and did 10. Well, let's try this. 10 to the cubed. If that's going to be it, then I know that my cubic units is going to be 1,000. Right? So I'd have to bring, basically what I'd have to do is I'd have to bring this, let's see if I can get my thing to work here. I would have to bring this all the way down to 1,000 in order for this line actually won't work anymore. So imagine 10 is going to be here, so that my point, or the point where that line's going to graph, would probably be right about here. So I imagine right here is going to be 10. Okay, so it's going to be very, very, very steep in order for me to get to find out what if I was to do that with a graph. Really tough to do. Okay, so thing is though, for B2, double I, that would be 1,000 cubic units. Very tough to solve graphically. Okay?